Okay, this mole review was given depending on when I saw you. It was either given on yesterday, but some of you got it the day before just because of midterms. I saw different classes, different periods. But I am going to help you get through this worksheet. Do not do number 1, 6, or number 7. And I'm going to come back and teach you how to do those, so you do need to keep this packet. When you complete all the other questions, aside from number 1, number 6, and number 7, show it to me so I can check your work. I'll give you a stamp, and then we will come back to finish number 1, 6, and 7. So we are going to start on number 2. If you ever see a problem with additional boxes, you can go ahead and cross this out. Okay? And I'm also going to attach in the classroom on this same thread, on the same post, about the rules. I'll say it now, but in case you need a reminder, if you ever see the word grams in a problem, you're going to look to the periodic table. I'll just shorthand it. Grams, you go to the periodic table. If you ever see formula units, atoms, molecules, or particles, you will always use Avogadro's number. And lastly, if you ever see like a blank spot and then mole, or it can be spelled like this, these are the same things. Mole or mole are the same things. Just know that this or this does not stand for molecules. These are two different things. So if you have a blank spot and then a mole, you always put the number 1. If you want to write that on your periodic table or somewhere in your notebook, that'll help you. If, however, it says moles, like number 4, it says a number and then moles, you do write that number down, and then down here where you write blank mole is where you put your 1 mole. If it tells you to put a number in front of mole in the question, you write down that number. But when you're just trying to match the units, you can go ahead and put number 1. Okay, so back to number 2. The number in the problem goes here. If this is grams of NaCl, what does this have to be? Okay, these two have to match, not the number. Do not include that number. Only the symbols have to match. Grams of NaCl. And what are we looking for? It says how many formula units. Whatever you're looking for goes in your top right. In case you need a reminder, I'll write it here. The number from the question goes in your top left. Whatever you're looking for, the unit goes in your top right. And then these two units have to match. Therefore, if that says grams, this says grams. If this says atoms, this says atoms. If this is molecules, this is molecules. So this is formula units. What number do we always use for formula units? It says it right here. So we go ahead and put Avogadro's number. Okay, grams of NaCl. If we ever see the grams, where do we look? We go to the periodic table. So I need to look up the mass of Na and Cl. So I'm going to grab my periodic table. Na is going to be number 11. Atomic number 11, and the mass is 22.99. And chlorine is 35.45. You add these together to get the total mass. A lot of students are asking if they need to round, or what if they round. You need to keep 2 decimals, or 2 decimal places, 2 numbers after the decimal. Okay, just try to stay in the habit of that. If you wanted to round up, like put 22.10, that's fine. Here, if you want to put 35. This would stay 4, 5 because this is a 3 afterwards. So add those together. If you do or do not round, it does not mean that it's wrong. Just know that your answer won't be the same as everybody else's, and everybody else's won't be the same as yours, and that's perfectly fine, just as long as it's off a little bit. So this compound, NaCl, weighs 58.44 grams because I added them together. Okay, and we just finished that problem. We just need to type it into the calculator. So side by side, these two are going to get multiplied, and we divide by this bottom number. 3.6 times Avogadro's number equals, then I hit the divide sign, 58.44. My final answer is 3.71 times 10 to the 22, or 3.7. These are the same exact answers. So it's answer choice D. Number 3, what is the correct molar mass for the compound? If you're looking for mass, you just look at the periodic table. Calcium is atomic number 20 and weighs 40.07. And bromine weighs 79.90. However, if you look, bromine has a 2 there, okay? If there's a subscript, whatever it's attached to counts for that element only, okay? That's telling you that, and you multiply. So there's 2 bromines here, so I need to multiply this by 2. If it's ever a subscript outside of parentheses, for example that, the subscript counts for everything in the parentheses, okay? If there's no parentheses, the subscript only counts for the element it's attached to. So this was just an example. So 79.90 times 2 gives me 159.8. I need to add these together to get the molar mass. It gives me 199.87. So this is my closest answer choice. You can go ahead and do number 4 and 5, number 8 and 9. I am going to do number 11 for you to remind you how to do it. A percent composition is you're just trying to find the percent, just like if you had an exam and you want to see what your grade was. So it's finding the percent. The formula to find the percent is going to be part over whole, and then times 100. So for instance, our midterm had 73 questions. That would be the whole. The whole is the entire number of whatever you're looking for. So on an exam, 73 is the total number of questions. Let's say you got 10 correct, so that's the part, and that's what would go on the top. So that's what part over whole means. Now when we're talking about compounds, it's asking the percent composition of CO, you're basing it off mass. And if it ever says mass, you need to go to the periodic table. It wants to know, out of this compound, whose mass has the most percentage that makes it up. So carbon is atomic number 6, and carbon weighs 12.011. Oxygen weighs 15.99. We need to add these up to get our whole. Okay, we need the denominator. So 12.011 plus 15.99, and that's going to give us 28.001, so I'm fine leaving it as 28. So you are finding 2%. The percent for carbon and the percent for oxygen in this compound. Okay, look how much carbon weighs and look how much oxygen weighs. If you were to guess who's going to have the higher percentage, who has more mass, who takes up most of this molecule composition. Okay, so let's check it out. The whole number goes on the bottom for both. Okay, it goes on the bottom for both of them. Carbon's mass, though, was 12.011. Oxygen's mass was 15.99. And that is how you're going to figure out the percentages for each. So in your calculator, I'll start with carbon, 12.011 divided by 28. That gave me 0.428. I times by 100. It gives me 42.89%. That's how much carbon there is. Now for oxygen, I just plug it into the calculator. I got 0.57 times 100 is 57.1%. That is for oxygen. This is for carbon. If you guessed at the beginning who is going to have the higher percentage based off of their mass, and you said oxygen, and we look at the percentages, oxygen is higher because oxygen weighed more. Okay, so that is, if you're not getting what you predicted and the mass was more, then redo your calculations. So if you need to watch that again to get you through the next one, go ahead, because number 12 is similar and I want you to do it on your own. You're finding percents. Keep in mind there's 2 chlorine, so multiply the weight of chlorine by 2. If you need to pause the video, do so now. Going to the next one. A lot of students had trouble on number 13. I think it was just the way it's worded. If that says mole, this has to say mole. What are you looking for? Calculate the number of atoms. What number do we always put in front of mole? What number goes in front of atoms? And that's how you do it, just like any other one. And then type into the calculator. 132 times Avogadro's number. And that's your answer. You owe me the rest of the worksheet. This is one of the first grades in the grade book on the third 6 weeks.